this video, we're going to go over our next derivative rule, the product rule. And we're going to jump straight into an example. Determine the derivative of y is equal to x cubed times x squared plus 2. Now this equation is a little bit different than what we've looked at previously, as I have the product of two expressions, x cubed times x squared plus 2. So we've never dealt with having to multiply two expressions like this. Now there are a variety of different approaches I could use to solve for this derivative, but today's objective is to teach about the product rule, and this is a great example to illustrate that. So the reason this is perfect for the product rule is because what I'm looking at here is the product of two expressions where I might consider x cubed to be f of x, and I might consider x squared plus 2 to be g of x. And what I'm examining here is the product of those two expressions. I could in fact rewrite this expression as f of x times g of x, where f of x is equal to x cubed and g of x is equal to x squared plus 2. Now I'm just going to jump to showing what the product rule is. The product rule gets used when we have a function that is f of x, some expression involving x, times g of x, another expression involving x. And to do the derivative, what I do is I take the derivative of the f of x term, f prime of x, times the original g of x, plus the original f of x term times the derivative of g of x, g prime of x. And that's the general form of the product rule to solve for the derivative of the product of two functions. So I've already got my f of x and my g of x, but I still need to solve for my f prime of x and my g prime of x. So let's do that next. For f prime of x, it's going to be the derivative of x cubed. So I'm going to take that exponent 3 times x to the power of 3 minus 1 or 2. For the derivative of g of x, g prime of x, what I'm going to do is I'm going to take the derivative of x squared first. So I take the exponent 2 times x to the power of 2 minus 1. That leaves me with just 1x, plus the derivative of 2, that's 0. So we can just ignore this last term. Now to put this all together to form our derivative dy over dx, recognizing that this is going to be f prime of x times g of x plus f of x times g prime of x. Now I substitute the expressions I came up with for f prime of x as 3x squared times my g of x, which is x squared plus 2. Then I add to that my f of x, which is x cubed, times my g of x, which is just 2x. And that essentially is the product rule. Now the next step is to clean this up, but we have done the product rule. We're just going to simplify it now. I multiply 3x squared times x squared, and I get 3x to the power of 4, plus 3x squared times 2, and that gives me 6x squared. Here I'm going to have x cubed times 2x, and that's going to give me 2x to the power of 4. Now I collect my like terms that I have here for x to the power of 4. So I have 3 plus 2x to the power of 4, giving me 5x to the power of 4, plus 6x squared. And there is my derivative dy over dx. And that's pretty much it. That's the product rule of derivatives. Now, like I said before, there were other ways I could have done this. I could have multiplied x cubed into this expression to begin with and done the derivative using the power rule alone. And to be honest, that probably would have been easier. However, this was a great example to introduce the product rule because sometimes this foiling out of an equation isn't an easy option and it can get quite ugly to do, in which case you would shift to the product rule of derivatives. So let's summarize what we just did. We have the product rule of derivatives, and it's when we have two expressions, in this case of x, being multiplied. And we determine the derivative by taking the derivative of f of x, this term, times the original g of x, plus the original f of x, times the derivative of g of x, this term. And that's how we calculate the product rule of derivatives. Let's do one more example to solidify this concept. Here we're going to determine the derivative of y is equal to x squared minus 1 times 3x squared minus 2x minus 1. So in this example, I have the product between two functions, x squared minus 1, which will be my f of x, and 3x squared minus 2x minus 1, which could be my g of x. This is the product of those two expressions. And now using my product rule of derivatives, I'm going to look at my f of x, which is x squared minus 1, and I know I'm also going to need its derivative, f prime of x. And this is going to be the derivative of x squared, which is going to be 2x, minus the derivative of 1, which is 0. So I'll just leave that at 2x. And then I have my g of x term of 3x squared minus 2x minus 1. And the derivative of this, g prime of x, is going to be 3 times the derivative of x squared, which is 2x, minus 2 times the derivative of x, which is just 1, minus the derivative of 1, which is 0. I can simplify this a bit further. That's going to be 6x minus 2. So now I'm going to take my f of x, g of x, and their associated derivatives, and I'm going to substitute that into my derivative equation. And so my derivative, and this time I'll write y prime, is going to be equal to f prime of x times g of x plus f of x times g prime of x. And so now it's just a matter of substituting the associated expressions. So f prime of x is equal to 2x times my original g of x, which is 3x squared minus 2x minus 1, plus my f of x, the original one, which was x squared minus 1, times my g prime of x, which is 6x minus 2. From here, I just FOIL my equation. So I have 2x times 3x squared, giving me 6x cubed, minus 2x times 2x, giving me 4x squared, minus 1 times 2x, giving me negative 2x here, plus I have x squared times 6x, which is 6x cubed, minus 2 times x squared gives me minus 2x squared. Then I have minus 1 times 6x, giving me negative 6x, or minus 6x. And then I have minus 1 times minus 2, giving me plus 2. Now I collect like terms. So I have 6x cubed and 6x cubed here. So that's going to total up to 12x cubed. I have negative 4x squared and negative 2x squared here. So that's going to total up to negative 6x squared. I have negative 2x and negative 6x, so those total up to negative 8x. And then I have this lone plus 2 at the end. And there is the expression for the derivative. And that's the product rule of derivatives. Now you try some.